All right, welcome back to Algebra 2. This is Unit 4.3. We're going to be looking at rational exponents. So exponents that can be fractions. We're going to look at how we can work with those, and then how we can convert into radicals. So first of all, we want to look at 3 to what power equals 9. All right, so we're looking at what exponent can we raise through to 3 to get 9. And so hopefully you see that it's 2. Right, so we know 3 squared is equal to 9. Well, how can we write the inverse of that exponent? So we're looking at 9 to what power equals 3. So we can kind of throw some numbers in and try to guess what it would be. Well, we know that 9 to the first power is equal to 9. And we know 9 to the second power is equal to 81. We can see already we're getting too big. We need it to be 3. So we got to go smaller than 1. Well, let's say 9 to the 0 is equal to 1, because anything to the 0 is 1, but now we're too small. So we know the answer has to be somewhere between 9 to the first and 9 to the 0, because we're trying to get it to be 3. So we need some kind of a fraction between 0 and 1. And so now we could just kind of start playing around with some fractions, and we can see, you could even use your calculator, that 9 to the 1/2 power is going to equal 3. All right, well, we also know that we could do a radical, okay, the square root of 9. We also know that the square root of 9 is also 3. Well, if the square root of 9 equals 3 and 9 to the 1/2 equals 3, that means that they must be equal to each other, right? So that means that a square root is equal to a fractional exponent. All right, so we want to remember our exponent rules. So we're going to go over those real quick. So x to the a power times, okay, we're multiplying, x to the b. When we're multiplying like bases, x is our base. So when we multiply like bases, we can carry the base across and add the exponents. All right, so for example, x to the 4th times x to the 5th is equal to x to the 4 plus 5, or x to the 9. All right, so add the exponents. Likewise on b, when we have an exponent and it's being raised to an exponent, we can bring our exponent from the outside, bring it on the inside, and multiply. All right, so x to the a times yb all raised to the c power becomes x to the ac times y to the bc. All right, so now with throwing some numbers in there, we can see that 2x to the 3rd all raised to the 2nd power, since that 2 on the inside has an exponent 1, this 2 on the outside gets distributed, okay, and gets multiplied to all the exponents, and then you can multiply that out, and you get 4x to the 6th power. When we're dividing, we want to remember to subtract exponents. So we always bring the smaller exponent to where the bigger one is to do the subtraction. Again, you can see the example x to the 8 over x to the 3rd. We bring the 3 up to do the subtraction, and then we get x to the 5th power. All right, so we have this rule that says that if x is raised to a fractional exponent, then we can convert it to a radical. All right, so you want to see where the different variables go. So the denominator b, that's the base of the exponent, or the denominator, becomes the index for the radical. All right, and then the numerator of the fraction goes in as an exponent on the inside. Now we can also use parentheses and put the exponent on the outside of the parentheses. All right, so that would be the same thing. All right, so let's go ahead and do each of these. We're going to convert from one form to the other form. So x to the 1/3, if we want to convert it to a radical, that 3 becomes the index, okay, of the radical, and then the x is our base that goes on the inside, and it's raised to the 1st power, and that's our exponent. So you can put a 1 there, and you don't have to put the 1, so we could just say the cube root of x. Okay, so again, there's that 1 on the x. All right, y to the 3/2. The 2 is the denominator, so that becomes the index of the radical, and then y to the 3rd. Now, because it's index 2, You don't have to put it. It means square root. And so most of the time you're not going to see a little 2 written for a square root. It's just not going to have a number there. So it's assumed that it's 2. All right. So 3x to the 5/4. So here the whole 3x is going to go underneath the radical with the 4 on the outside. And so we put 3x. Now the whole thing is being raised to the 5th power. So here we want to put parentheses around the whole thing and then put a 5 on the outside. So you can't just put 5 on the x on the inside. It would have to be on the 3 and the 5 and the x. So that's why we use parentheses. All right, let's see. Now we have a radical and we want to convert to an exponent. So the whole 6x to the 5th is being raised or underneath the radical. So the whole 6x to the 5th has to have a fractional exponent, right? So 6x to the 5th, and that's going to all be raised to the 1/2 power, right? So again, there's a 2 here, and then this whole thing really has a 1 on the outside. All right, the cube root of x squared, so this becomes x to the 2/3 power, 2/3. 2xy to the 1/2, so the 2 in the denominator becomes the radical, so this is going to be a square root. 2xy, and the whole thing is being raised to the 1st power. The 4th root of 5x, so 5x is all being raised, okay, to the 1/4 power. Again, you can kind of look at it like that with the 1 on the outside. All right, so let's keep going. So now we're going to go ahead and simplify each of these. So most of the time when you're given a fractional exponent, it's easier to simplify if you convert it to a radical. All right, so 8 to the 1/3 power. So we're going to convert this to a radical. So this is going to be the cube root of 8. And so the cube root of 8, you can simplify. You're just trying to find a number that multiplies by itself 3 times. And so we know that that has to be 2. Because 2 times 2 times 2 is 8. All right, B, the 16 to the 5/2, 16 to the 5/2. So that's going to be the square root of 16. And this whole thing's going to be raised to the 5th. So what I'm going to do is put it all in parentheses, put the 5 on the outside. Now what I can do is simplify the inside number. So the square root of 16 I know is 4. And that's all being raised to the 5th power. And then I can multiply 4 to the 5th power out. So here I can just take my calculator, put in 4 and raise it to the 5th power. So it's 1024. All right, 27 to the 2/3. So here we're going to put the 3 for index of the radical. 27 goes inside. Now I'm going to use parentheses and raise it to the 2nd power. Now I'm going to simplify the cube root of 27. So find a number that multiplies by itself 3 times. That equals 27. And it's going to be 3. And I'm going to raise that to the 2nd power. And so the answer is 9. All right, D, 100 to the negative 3/2. So when there's a negative exponent, that negative has to go to the numerator. It can never go to the denominator. Because when we write it as a radical, that 2, okay, is a square root, and it has to be a positive number. Okay, so I have that square root of 100, and I'm going to raise it to the negative 3 power. Well, square root of 100 I know is 10. Now when I raise it to the negative 3, if you remember when we had negative exponents, okay, this whole thing really says it's over 1. I can take it and flip it to the denominator to make it a positive exponent. Okay, so it becomes 10 to the positive 3 on the bottom. But I have to leave something on top, so I'm going to put the 1 on top. Now 10 to the 3rd can be multiplied out. 10 times 10 times 10. So it's going to be 1 over 1,000. Right, so 10 to the negative 3 power is 1 over 1,000. All right, so let's keep going. 9/4 to the negative half. So again, I'm going to make this a radical. It's the square root of 9/4 raised to the negative 1 power. So I can simplify square root of 9/4. So if you remember when we did radicals earlier, you can split this up into the square root of 9 over the square root of 4, and that simplifies to 3/2 to the negative 1. But then you can bring that negative 1 on the inside, so it's 3 to the negative 1 over 2 to the negative 1. And with negative exponents, you can flip them. So now it becomes 2 to the first on top and 3 to the first on the bottom. So 2/3. All right, F. Here, I want to change this to a fractional exponent. Okay, so this is going to be 562, and I have that 4 exponent, so that's going to go on top, and this 4 index goes to the denominator. So it looks like that. 562 raised to the 4/4. Well, 4/4 simplifies to 1, and so that's really the same as 562. All right, G. Same thing. I have a negative 125 to the third, all under the cube root. So I can do the same thing. So I have negative 125, and I'm raising it to the 3/3 power. Well, 3/3 is 1, so negative 125. All right, H. I'm back to a fractional exponent, so I'm going to convert it to a radical. So the square root of 36, all raised to the 3rd power. Okay, so the square root of 36 is 6, raised to the 3rd. I can take my calculator. 6 raised to the 3rd power, 216. All right, so remember, when you don't see a number in the radical, okay, in that index position, then it has to be a 2. And so if you know it's a 2 down here, then you don't have to put it. You just know it's already 2. All right, I'm going to convert this to a radical. So it's the square root, 4x squared, and that's all raised to the 1st power. And then now I can simplify the square root of 4, that's 2, and the square root of x squared is x. All right, J, I'm going to convert this to a radical, so cube root 27x6 all squared. So I want to simplify each of these. The cube root of 27 is 3. The cube root of x to the 6th is 2, x squared, sorry, 3x squared. Fix that. And that's all raised to the 2nd power. Now 3x squared squared becomes 9x to the 4th. All right. On this one, you could have seen that 27 is raised to the 1st and bring that 2/3 in by multiplying. Right, and then 27 to the 2/3 power, you can convert that to a radical and simplify it. It goes down to 9. And then the x to the 6th to the 2/3 power, you could have multiplied those together. 6 times 2/3, that would be x to the 4th power. So that's how you get x to the 4th another way. All right, K, let's see, we can convert this to a radical. So negative 8x to the 9, that's the cube root, and it's all raised to the 4th power. The cube root of negative 8, well, that's negative 2, because negative 2 times negative 2 times negative 2 is negative 8. The cube root of x to the 9 is x to the 3rd. Okay, and that's all raised to the 4th power. So now I can bring that 4 inside and multiply. So negative 2 to the 4th power means negative 2 times negative 2 times negative 2 times negative 2, and that's positive 16. And then x to the 3rd to the 4th becomes x to the 12. All right, last one. Convert this to a radical. 256x8. We have a 4th root, all raised to the 5th power. All right, the 4th root of 256. Now you can find a number that multiplies by itself 4 times. That equals 256. So I take my calculator. So it's 4. Then the 4th root of x to the 8 is x squared. All that is being raised to the 5th power. So now I can bring that exponent 5 in and multiply. So 4 to the 5th power can get multiplied back out. So 4 raised to the 5th is 1024. And then x to the 10 power. 2 times 5 is 10. All right, and that is it.